Having introduced trigonometric functions at sort of a low level, let's talk about the actual definitions. So again, a trigonometric function is typically defined on an angle. So I'll input an angle. So let's let theta be this angle. So our picture is something like this. I have one angle, which is the right angle, and then another angle, which I'll call theta. Assume it's not the right angle for now. There are three sides to this triangle. The longest one is what's called the hypotenuse. It's opposite the right angle. That is, the right angle is here and the hypotenuse is there. That's what's typically meant by opposite here. We'll call the side directly opposite theta opposite. We'll call it OPP, just shorthand for opposite. And then the angle the side that is adjacent to theta, the remaining one, we'll call ADJ, adjacent. So with this labeling of the sides of the triangle, we can now define the major trigonometric functions. So let me redraw the triangle here. Adjacent, hypotenuse. So sine is a function of theta, and it's defined to be the length of the opposite side over the length of the hypotenuse. So op over hypotenuse. That's sine. Cosine is defined as adjacent over hypotenuse. So this one over that. And then tangent is simply opposite over adjacent. So these trigonometric functions are just ratios of sides of this triangle. They're just relationships among the sides. So let's look at an example here. So I want to ask questions about this angle theta, which means I'm going to have to give you lengths of the sides. So let's try 4, 3, and 5. So what is sine of theta equal to? Well, it's opposite over hypotenuse. Op over hyp. So 4 divided by 5. Easy. I just had to remember what sine means. It's defined to be the ratio of those two sides. Cosine of theta is adjacent over hypotenuse. So 3 over 5. And tangent of theta is opposite over adjacent, which in this case is 4/3. So in this case, this is not too bad, I don't think. You just have to remember what these definitions are. Let's look at another one. So let's look at one that's 13, 12, and 5. And an important question for those of you who are really paying attention is, are these actually side lengths of a right triangle? Do they satisfy the Pythagorean theorem? The answer is yes. 5, 12, 13 can be lengths of a right triangle. So again, we'll play the same game, just practicing what these definitions are. So if this is theta, sine of theta is opposite over hypotenuse. So 12 over 13. Cosine of theta is adjacent over hypotenuse. So 5 over 13. And tangent of theta is opposite over adjacent. So 12 over 5. Now, so we have discussed so far 3 trigonometric functions: sine, cosine, and tangent. Now, these are the foundation. These are the most significant ones, but there are other examples. The other 3 we consider are very much related to sine, cosine, and tangent. These are cosecant, secant, and cotangent. And they're basically defined by saying, flip the ratios in question. Cosecant is the same as sine, except the ratios are flipped. So I do hypotenuse over adjacent, over opposite. For secant, this is the same as cosine, except I flip. So I do hypotenuse over adjacent. And for cotangent, I do not tangent, which is opposite over adjacent, but adjacent over opposite. So let's look at the definitions. Secant of theta is hypotenuse over adjacent, which, if you'll notice, is 1 over cosine of theta. Cosecant is hypotenuse over opposite, which is 1 over sine of theta. And cotangent's adjacent over opposite, so 1 over tangent of theta. So let's look at the same pictures. Secant of theta is hypotenuse over adjacent, so 5 over 3. Cosecant of theta is hypotenuse over opposite, so 5 over 4. And cotangent is adjacent over opposite, so 3/4. And you can check that these are the same as sine, cosine, and tangent, but reciprocal. Let's look at our tall triangle again. Well, that's very lousy. So secant of theta is adjacent over hypotenuse. So 5, that would be cosine. So it's actually hypotenuse over adjacent. So 13 divided by 5. Cosecant is hypotenuse over opposite, so 13 over 12. And cotangent is adjacent over opposite, so 5 divided by 12. Okay, so not too bad, I don't think. Keep in mind these are just the foundations of trigonometry. We'll look at many more examples of these things.